What if I told you that every time you stick a magnet to your fridge, you're touching a mystery that even the greatest physicists struggled to explain? Not a trick, not a simple force, but a hidden rule of reality that quietly controls how matter itself holds together. Richard Feynman once said that no one truly understands why magnets work, not in the deep, satisfying way we understand things like gears or falling objects. And that statement alone should make you pause, because if we can't fully explain something this ordinary, what does that say about how much of the universe we really grasp? Right now, as you're watching this, invisible lines of influence are stretching through space around you. You can't see them, you can't feel them, but they are shaping the position of every metal object in the room. Bring two magnets close together, and suddenly they either leap toward each other or push away like they're alive. No strings, no contact, just motion, as if space itself has decided to take sides. Feynman loved this kind of question because it exposes a dangerous habit in the human mind. We think naming something means we've explained it. We say magnetic force and feel satisfied, as if the label is the same as understanding. But Feynman would stop you right there. He'd ask, what do you really mean by force? Is it a push? A pull? A message traveling through empty space? Or something even stranger that doesn't fit into everyday language at all? Imagine trying to explain magnetism to someone who has never seen or felt a magnet. You could talk about north and south poles, about fields and attraction, about electrons spinning inside atoms. But at the end of the day, you'd still be pointing at equations and models, not the thing itself. You'd be describing the shadow of a process that happens in a realm far smaller and far deeper than your senses can reach. This is where the story gets unsettling, because magnetism isn't just a weird property of special rocks or shiny fridge toys. It's woven into the fabric of matter. The same hidden rules that make magnets snap together also help hold atoms in place, shape the chemistry of your body, and determine how light interacts with the world around you. In other words, what feels like a simple trick of nature is actually a window into the engine room of reality. And here's the uncomfortable truth Feynman wanted people to sit with. When you ask, why do magnets work? You're not just asking about magnets. You're asking why the universe has the rules it does at all. Why space can carry influence. Why invisible things can move visible ones. Why the world doesn't fall apart into chaos. Because once you really look at a magnet, not as a toy, but as a clue, you realize something quietly shocking. Magnets aren't just wrong. They're telling you that reality itself is far stranger than it looks. To really feel how strange magnets are, you have to shrink your imagination down to a scale you've never experienced. Not the size of a room, not even the size of a grain of sand. We're going inside the atom, into a world where the rules of everyday life stop working the way you expect. Every piece of metal in your hand is made of countless atoms, and inside each atom are tiny charged particles called electrons. These electrons don't just sit still like marbles in a jar. They move, they spin, and they behave in ways that are more like waves of probability than solid objects. According to Feynman, this is where magnetism really begins, not in the magnet you see, but in the invisible dance happening deep inside matter. Here's the part that sounds almost unreal. Each electron acts like a microscopic magnet. Because of its motion and an intrinsic property called spin, it creates a tiny magnetic field around itself. On their own, these little fields usually point in random directions, canceling each other out. That's why most objects in your house don't stick to the fridge. But in a magnet, something special happens. In certain materials, huge numbers of these electron magnets line up like a perfectly drilled army. When that alignment spreads across millions and millions of atoms, their tiny fields combine into one powerful, invisible presence that reaches out into the space around the magnet. What you feel as attraction or repulsion is really the collective whisper of countless electrons acting in unison. Feynman loved to point out how unsatisfying this explanation can feel, because if you ask, okay, but why do electrons have this property at all? Physics doesn't give you a neat, comforting answer. It gives you a deeper rule, a mathematical description that works perfectly, predicts everything we see, and yet doesn't tell you why the universe chose that rule instead of some other one. This is where magnetism stops being a simple story and starts becoming a philosophical problem. The moment you explain it, you've just pushed the mystery one layer deeper. You've traded why do magnets stick together for why do electrons behave like tiny magnets? And then inevitably, why do the laws of nature allow that to happen? What's even more unsettling is how familiar this pattern is. Gravity, light, electricity, they all work the same way. We describe them with stunning precision. We can build machines, predict outcomes, and send spacecraft across the solar system. But when it comes to the deepest why, we hit a wall. The universe answers us with equations, not with reasons. So when you watch two magnets snap together, you're not just seeing a clever trick of physics. You're seeing the surface of a much deeper reality, a reality where matter, motion, and invisible rules are woven together in ways no human intuition was ever designed to fully grasp. And that raises a disturbing possibility. If magnetism is built into the very structure of atoms, and atoms are built into everything you are and everything you touch, then the same hidden rules pulling metal across a table are also shaping the thoughts in your mind, the beating of your heart, and the chemistry of life itself. Which means the mystery isn't just out there in the world. It's inside you too. Now here's where Feynman really flips the way you think about magnets and about forces in general. When you see two magnets pull toward each other, your brain automatically imagines something reaching across the empty space between them, like invisible strings, or a hidden hand grabbing one and dragging it closer. But in modern physics, that picture is completely wrong. According to the deeper rules of the universe, there is no solid thing traveling from one magnet to the other. Instead, what exists is a field. A magnetic field isn't an object you can hold. It's more like a condition of space itself. The space around a magnet is different from empty space far away from it. It has a kind of tension built into it, a structure that tells charged particles and other magnets how they are allowed to move. Feynman described this as one of the strangest ideas in all of science, because it means nothing is really pulling on anything. The magnet on your table isn't being dragged toward the other one. It's simply moving along the only path the field allows. Think of it like a landscape instead of a force. If you drop a ball on a hill, the hill doesn't reach out and grab the ball. The shape of the hill just makes certain directions downhill and others uphill. The ball follows the shape of the terrain. In the same way, a magnetic field shapes the invisible terrain of space, and objects move through it accordingly. But here's the part that gets unsettling. Where does that field live? It's not inside the magnet. It's not inside the air. It's not even inside the space between the magnets in the way we normally think about inside. The field is the space. It's a property of reality itself, written into the fabric of the universe. And suddenly, magnetism stops being a story about metal and electrons. It becomes a story about what space is allowed to be. This is why Feynman warned people not to be too satisfied with simple explanations. You can say, magnets work because of fields, but then the next question hits you like a wall. Okay, but what is a field really? Physics answers with equations that work with terrifying accuracy. They tell you how strong the field is at every point, how it changes, how fast its influence can spread. But when you ask what a field is, in a deep human sense, the answer slips through your fingers. It's not a substance. It's not a wave in something else. It's more like a rule that reality follows everywhere, all at once. And that leads to an even stranger thought. If space itself can carry information about magnets, charges, and energy, then empty space isn't empty at all. It's a hidden stage, filled with invisible structure, constantly shaping how matter and light, and even time itself, are allowed to behave. So when two magnets move toward each other, you're not watching a simple pull. You're watching the geometry of the universe quietly rearrange itself, and matter has no choice but to follow. This is where Feynman connects magnets to something even more shocking, light itself. Because the same idea that explains why magnets move also explains why light can travel through nothing. If space were truly empty, light would have nothing to move through. No air, no water, no material at all. And yet, a beam of light can cross the cold vacuum between stars for millions of years and arrive with perfect precision. So what is it moving through? According to modern physics, it's moving through the same kind of invisible structure that creates magnetic fields. Light is not a ripple in air or in space, like a wave on water. It is a vibration of the electromagnetic field, the same deep field that gives rise to electricity and magnetism. This means when you turn on a flashlight, you are not throwing something across the room. You are disturbing the fabric of the electromagnetic field right where you stand. That disturbance spreads outward, carried by the rules of the field itself. And here's the part that sounds almost impossible. That spread has a hard limit. No matter how powerful the source is, no matter how empty the space is, no matter how desperate the message is, that disturbance cannot move faster than the speed of light. Feynman loved pointing out how strange this really is, because it means the universe has a built-in speed limit, written directly into the structure of reality. It's not a law humans invented. It's not a rule we discovered and could someday break. It's more like a property of space itself. Imagine space as a kind of cosmic grid. Every point is connected to its neighbors by invisible rules. When something changes at one point, a charge moves, a magnet shifts, a light turns on. That change must be handed off from point to point across the grid. And the grid can only pass that information along at one speed. That's why nothing can outrun light. Not because engines aren't strong enough, but because the universe itself refuses to pass along cause and effect any faster than that. And now, go back to magnets. When you move a magnet, the magnetic field around it changes, but that change doesn't update everywhere in the universe instantly. It spreads outward at the same maximum speed as light. Even magnetism obeys the same cosmic limit. So suddenly, magnets and light are no longer separate mysteries. They are two faces of the same deeper reality. And that leads to a terrifying and beautiful idea. What we call space is not just a backdrop where events happen. It's an active participant. It decides how fast things can move. It decides how causes can reach effects. It decides what is even possible in the first place. You're not living in an empty container called the universe. You're living inside a rule book. A living, invisible framework that quietly governs every spark, every pull, every beam of light, and every thought you've ever had. And the speed of light is not just a number. It's the universe telling you how fast reality itself is allowed to change. Now that you see how magnets and light follow the same hidden rules, Feynman takes the question one step deeper, into time itself. Because if nothing can move faster than light, that means something even stranger is happening. It's not just objects that are limited, it's events. Imagine two moments in the universe, one here, one far away. For one moment to affect the other, the information about that change has to travel between them. And since nothing can move faster than light, there's a built-in delay between cause and effect across space. Feynman loved this idea because it flips how we normally think. We imagine time as a single, universal clock ticking the same everywhere, but the speed of light says that can't be true. Different parts of the universe are always slightly out of sync, depending on how far apart they are and how fast they're moving. This is where Einstein's relativity enters the story. But you don't need equations to feel how wild it is. If you could somehow ride a beam of light, the universe ahead of you wouldn't just look different. Time itself would behave differently. Events that seem separated to someone standing still would blur together for you. The order of before and after depends on how you move. And here's the unsettling part. The universe doesn't just have a speed limit. It has a causality limit. There are events that are simply too far away or too soon for you to ever influence, no matter how advanced your technology becomes. Not because you're weak, but because the structure of space-time won't allow a connection to form. Feynman used to say that physics is about finding the rules of the game, and this rule is one of the deepest. Causes cannot outrun light. Think about what that means for something as simple as now. When you look at the stars in the night sky, you're not seeing them as they are. You're seeing them as they were, sometimes thousands, sometimes millions of years ago. Your present is actually a mosaic of the past, stitched together by light arriving at different times. Even the person sitting across from you is not, in a strict sense, happening at exactly the same now as you. There's a tiny delay, unimaginably small but real, as light carries their image to your eyes. So the universe doesn't share a single moment. It shares a web of moments, connected only as fast as light allows. And here's where Feynman brings it back to you. Every thought you have, every nerve signal in your body, every heartbeat in your chest also obeys this same rule. Signals in your brain move at finite speeds. Your sense of a smooth, continuous self is built from countless tiny delays and handoffs happening inside you. Which means the speed of light isn't just a cosmic limit out there among stars and galaxies. It's a quiet architect of your own experience of reality. You don't just live in a universe with a speed limit, you are a process shaped by it. And this is where everything Feynman showed you quietly comes together. Magnets, light, time, thought. They don't feel connected in daily life, but at the deepest level, they all follow the same invisible rule. The universe only allows reality to be built at a finite speed. There is no instant, no absolute now that exists everywhere at once. Everything that happens locally first, and then spreads outward, carried by signals that can never outrun light. That means the universe is not a frozen picture. It's a constantly updating process. Every star you see, every sound you hear, every memory you form is delayed. Not because something is wrong, but because that's the only way a universe with structure can exist. If effects could travel instantly, there would be no separation, no order, no meaning to cause and consequence. Everything would collapse into a single, undifferentiated moment. Feynman loved this because it turns a cold scientific limit into something almost philosophical. The speed of light isn't just a barrier. It's what creates the story of the universe. It's what allows one moment to follow another. It's what lets the past be different from the future. It's what gives the world a sense of flow instead of chaos. And here's the part most people never realize. You are not just observing this rule from the outside. You are built from it. Every thought you have is a signal traveling through networks of neurons. Every decision you make is a cascade of tiny physical events, each one waiting for the next to arrive. Even your awareness of this very sentence exists because light from a screen or sound from a speaker is crossing space to reach you, right now. So when you ask why light shouldn't be this fast, what you're really asking is something deeper. Why does reality feel like a sequence instead of a blur? Feynman's answer, in his own playful way, was that nature doesn't give us the universe all at once. It hands it to us piece by piece, limited by how fast information can move. And that limitation is what makes discovery possible. It's what lets questions exist before answers. It's what allows mysteries to unfold instead of appearing fully formed. It's why you can look up at the sky and feel wonder instead of certainty. Because if everything were instant, nothing would ever be revealed. So the next time you see a beam of light cut through the darkness, don't just think of it as something fast. Think of it as the messenger that carries reality itself from one moment to the next, not breaking the universe, but quietly holding it together.